They said it couldn't be done, so I did it. 3 episodes. Landon's Lucrative Learnings. Part 3, nested loops. It's getting serious. We skipped over for loops. You'll be fine. You don't need it. I mean, you do need it, but we'll cover that real quick. Don't even worry. Don't you worry. What are loops? This is a bit of a recap, but we do have to include 2 new loops here. There are 3 types of loops: the while loop, the do while loop, and the for loop. The do while loop essentially is the same as a while loop, except it takes what's inside of the loop and puts it at the start. So it runs, do this, and then it checks the condition. This is great if you want to like initialize something before you check the condition. And the for loop, we'll get into it in just a second. But these allow us to output some form of code until a condition is met. And the difference between a for loop and a while loop is that a for loop runs as many times as you initiate a variable. So if you say for this loop, run it 10 times, it will run what's inside 10 times, essentially. If you run it from 1 to 13, how many times it would run it? It would run 12 times. That's just an idea. You can also run it where the initialized variable is going downwards. This is great if you're using that variable in some way, like if you're calling that to a list and you want to use that variable as an index. It has a lot of different ways to use the for loop. All right. Nested for loops. This is what we're here for. Nested for loops refer to putting a loop inside of another loop. If the outer loop uses the variable I and the inner loop j, then j will loop through all of its iterations every single time I iterates. So this is essentially an exponential process to get more information in less code. Instead of writing, if we were wanting to do this code without doing the nested loop process, you would have to write out the I code or the j code I times. So you'd have for this, for this, for this, for this, for this. Instead, we can just indent, put that loop, and every time the first loop runs, the second loop will run that many times. So it's great. And we can see at the bottom here, this is the output. That's exponentially more information than what one for loop would have given us. So that's what it's for. If we wanted to traverse a list of lists, we would have the outer loop be I from 0 to the number of lists, and then the inner loop would go from j to the number of indexes inside of the lists. We'll get into a more specific example of this in just a second. So a real world example of using nested loops would be printing the multiplication table. So here it is. Because it would be a lot of work to print each and every single number. I mean, there's 144 numbers in the basic multiplication table from 0 to 12. We can use a nested loop. And so this shows you that exponential process, right? Instead of it just being one row where we loop through from 0 to 12 and print them, right, which would be what one for loop does. Now we want to print that times itself, essentially. So this is a squared process. That's what I mean by exponential. There's squared amount of more information than we had before. And so to account for that, the for loop makes it easy for us to account for that vastly more information. So in this case, because it would be a lot of work to print every term, we can have a loop for the number of columns or the rows, or like how many numbers are in the row and how many numbers are in the columns, which we can also say is the same thing as the number of columns and then the number of numbers inside of each and every column, and which makes a square. And so we can essentially loop through each and every row. This allows us to loop through all of them, where I is the current row that we're on, and j is the current number we are on in that current row. So there we go. Thank you for listening. Hope you learned something today.